what if I can't use the limit laws? What if I don't know whether or not the limits exist? So for example, what if I have a limit that looks like this, the limit of x squared times the cosine of 10x? I would love to use the limit laws, and I know that eventually this limit's going to get me down to a limit of x, and I know that that equals 0 and that exists, but I don't really know anything about the limit of cosine of 10x. I don't know if it exists. And if I don't know that it exists, then I can't use the limit laws. So if I can't use the limit laws, then what? There's some tool here that's called the squeeze theorem, and it's a special case tool. It's like that one weird screwdriver that you almost never use, but when you need it, you need it. And it works like this. Let's say I've got a function f up here and some function underneath it, g. Now, if I know that the limit of f at a equals L, and I know that the limit of the function g also equals L, so if I look at the picture there, both of those two functions have the same height right at a. If I ever have this situation where I'm dealing with some third function, let's call it h of x, and let's say h of x is stuck between them. If h is stuck between f and g, when I start getting close to that location, the other two are going to squeeze together and force it to go to the same height. So it's going to force it to have the same limit. And that's what the squeeze theorem is all about. You can prove this squeeze theorem with epsilon delta, but we're not going to do that in this kind of case. The function I just showed you a moment ago has a cosine. Now, the hard work here is that if you can show me that there are two functions that kind of squeeze your function, then I can use this result to prove that the limit must exist as well. In your life, you should have learned about cosine functions, and one of the most important things that you know about a cosine is that its heights are always trapped between -1 and +1. Doesn't matter what its period is, it doesn't matter what's on the inside of cosine, what's important is that its heights are always restricted. So if I wanted to multiply the cosine by something to make this inequality still hold, I'll have to multiply everything in the inequality by that same expression. Now I'm lucky here, x squared is positive, so I don't really have to worry about whether I flip the signs or not. The function in the middle here is exactly the one that I start with in my limit. I have succeeded in trapping my function between two other things. The limit of x squared, I'm allowed to use the limit laws because I know that the limit of x exists. And this is just going to be 0. And I know that the same thing is going to hold for -x squared. I'm allowed to put the limit inside of the square and then put the negative out front. I've demonstrated that there are trapping functions that trap my function. I've demonstrated that their limits are the same at the point I'm interested in. And so the squeeze theorem allows me to conclude that it has to have the same limit. Now this might make your head spin a little bit, so a picture is in order here. X squared is a parabola. -x squared is just the upside down version of that parabola. If you were to take a graphing calculator and plot x squared times cosine of 10x, cosine of 10x is just a function with wibbles and wobbles, and the x squared in the front is just making its amplitude change. As I get closer to 0, the height of this blue wobbly function is getting closer to 0 as well. These functions are trapping it, so it has to squeeze down together and have a limit of 0. So the squeeze theorem is like your last ditch effort in some cases when you can't do anything else.